is Rolle's theorem. So today we're going to be talking about Rolle's theorem. So Rolle's theorem is essentially a special case of mean value theorem. So it's under the umbrella of mean value theorem. All of the rules for which apply to mean value theorem also apply to Rolle's theorem. So essentially, Rolle's theorem is where we know, with mean value theorem of course, that if you take the slope of the two endpoints on an interval, that we know that there must be a tangent line between those 2 points where the slope is the same as the slope of the secant line between the two endpoints. That's what mean value theorem states. Rolle's theorem is more specific than that. It's saying that if the two endpoints have the same y value, so do you see how these two endpoints have the same y value right here?
Yeah.
That must be the case that there must be a point within that interval that the tangent line is 0 at least once, okay? In this case, it happens 3 times. Here it happens only once, here it happens once, and then here it's everywhere in a constant function. So that's the main idea. Just be aware that this particular test, of course, there's the application problems, which are like 3.9, 4.1, 4.2, but also you've learned about some theorems, so you also have to be able to answer questions about the theorems and what rules apply to those theorems on the test. Okay, it's not just calculations.
And that's getting on a study guide, correct?
That's what?
Getting on a study guide.
It'll be on there, yeah, of course. Well, I prompt you to write them out. So, this is Rolle's theorem. This is the official theorem. It says if a function is continuous on a closed interval and differentiable on the interior interval, okay, just like mean value theorem. So same rules apply as mean value theorem, and then in addition to that, if you plug the endpoints into the function and they equal each other, the y values equal each other, then there must be a number between those values where the c value equals something where the slope is 0. Okay, so you're always going to be able to find a c value where the slope is 0 on the function. Yes, Brandon?
Why does it have to be the endpoints? Couldn't it just be if 2 points like have the same y value? It would at some point have a value of the slope of 0?
Yes, but the whole point is that we have to define those points. It always occurs between those 2 points, right? Where that thing is. You know what I'm saying? So like wherever those 2 points are, where the y value is the same, are what we are going to consider to be our endpoints.
Okay.
Yes.
Are you saying that it really only applies because we have the restrictions then?
Exactly.
Okay.
We don't know if it's the case unless we confirm all
Okay,
these things
understood.
first.
Okay.
Yeah, exactly. Yeah, we can't just pick any random 2 points. They have to have the same y value. So that's why Rolle's theorem doesn't hold unless the y values equal each other.
Well,
Otherwise,
he was saying like, if you have 2 y values that are not the endpoints, would it still apply?
no, because they're only asking you
They
about the
would be
endpoints.
They-
Yeah, we're
like,
treating
in that
those
case,
as
they
the
would be.
endpoints. They're asking
Yeah,
you
no.
if you
No, I
can.
got it.
Yeah.
I understand.
Okay.
I was just trying to figure out what you were asking.
Okay. So for this example, we have to go through all of the same checks that we have to go through for mean value theorem. So first thing we have to check is if it's continuous on the interval, and then if it's differentiable on the interior. So what type of function is this?
Quadratic!
Good, and you all know quadratic functions are what?
Continuous and differentiable.
Yeah, they're continuous and differentiable everywhere, so we don't really have to worry about what the interval is for this particular function. Of course, if it was a function that had some type of discontinuity, or we knew it had a cusp or a corner, we would have to check that. I'm just waiting for my tablet to turn on, so that's why I haven't written it yet, so just give me a minute.
And it's between
It turns itself off.
It's between -2 and 1.
Correct. So, differentiable and continuous everywhere, so of course it is differentiable and continuous over that particular interval. This is the third thing that's different from mean value theorem. We have to check that the endpoints, when plugged into the function, equal the same thing. So what you essentially have to do is you're going to have to plug those values into the function to confirm that. If this doesn't work out as expected, and they don't equal each other, then you would basically just say Rolle's theorem doesn't apply and move on. Okay, you wouldn't be able to solve the problem. So I'm just plugging this in. When you do the math here, you should get -2. So that means that we have a point at -2 comma -2 on our function. Okay, we're going to have to use that later, so might as well take care of both steps in one step. Now we're going to have to plug the other point in as well. And evaluate, and when you do that math, you're also going to get -2. So we also have a point 1 comma -2. Okay? So these endpoints, or these points, which are endpoints, are important because now we're going to, because they're the same, we know that any 2 points that have the same y value must have a slope of 0, right? Because if we do the math, okay, just to show you, this is going to be 0 over something. Doesn't really matter what, as long as the denominator is not 0, right? Anything but 0. So we got 0 over 3, which is what? 0. So this is the only time that Rolle's theorem works, is if the slope is 0. If it's anything but 0, it's just regular mean value theorem. Okay, that's what differentiates the two from each other. So now that we've determined that, we want to figure out what point on the function has a slope of 0. Okay, so to do that, we're going to take the derivative of this function. So what would be the derivative of this function?
-2 minus 4x.
Minus 4x, and we're going to set it equal to the slope that we just calculated, which is 0. We're going to solve. We're going to divide. And we're going to reduce. So I get x equals -1/2. So what that means is at the point on the function where x is 1/2, that we call that our c value. Okay, so our c value is -1/2. So if you look at the function, do you see how at the x value of -1/2, the slope is 0 right there?
Mm-hmm.
Yeah.
And then if you were to look at the secant line between the 2 points here and here, if we were to draw in a secant line, the slope of that line would be the same,
Yes, parallel.
and also 0. So that's the parallel part, comes from the mean value theorem. Rolle's theorem,
It's the tangent line and
the secant line. Exactly, but they're more specifically have to be 0 in this particular case. Yep. That's why it's a special case of mean value theorem. Alright, so the next one, we have to verify it's continuous and differentiable. So you should have a basic understanding of what a sine or cosine graph looks like. It's just like the up and down curves. Would this be continuous everywhere?
Yeah.
Yes, just a bunch of this repeating pattern. And would it be differentiable everywhere?
Yeah.
Yeah, no cusp corners or vertical tangents on that. So now what you have to do is you have to plug those endpoints in and ensure that the value that you get when you do that is the same as the value when you plug the other endpoint in. So basically that they match. So if you got to this point and you got a value that where they didn't match, you would just say Rolle's theorem does not apply. Okay, so just to be clear about what to expect there. So I'm plugging in pi over 2, negative pi over 2, which is -90, right, in terms of degrees. So this is sine of negative pi because the 2's are going to cancel. So if you're going to do this in the calculator, I highly recommend switching it to degrees because if you get an answer in radians, it's not going to put the radians in terms of pi. It's going to give you the actual decimal. So that's why it's easier to use degrees. So you have to be able to convert from radians to degrees. So if you do the math here, you're going to get -3 times 0 because sine of -180 is 0. So the answer here is
0.
just 0. So we know that our function has a point at negative pi over 2 comma 0. Now we have to do the same thing, but we're going to plug in regular pi over 2 instead of negative pi over 2, which is the other endpoint. And the 2's are going to cancel once again. And you're going to get -3 times, bless you, sine of pi. Sine of pi is sine of 180. So if you look at the unit circle at 180, it's 0.
It's 0.
It is 0. Cosine would be 1, but sine is 0. So it's going to be -3 times 0, which is also 0. Because think about it, -180 and 180, you're doing the same thing. Like if you were to turn around to the left versus the right, you're still.
Where should be 8?
I didn't get 8.
There's no 8 up
Where do you see an 8?
there. Where's 8 times pi divided by
That's 3.
That's a 3.
Where do you see an
Dude, that's
8?
definitely a 3.
That's a 3?
No,
Yes.
up there, that's
Yeah.
a 2, but it's crossed out.
Oh.
Oh, so, he's talking
Oh.
about that. I see that,
Yeah,
Oh,
prior
okay.
to it being
I'm so
crossed
sure.
out, it looked like a 2. I never write my 8s like that, so.
It looks like a good 8, but it's not an 8.
Sure, it looks like a weird 8.
I-
Alright, so is everybody good how we got these points?
Yes.
Now we have to find the slope between the 2 points, so m equals, it's going to be 0 minus 0 over pi over 2 minus a negative pi over 2. We don't really care what the bottom is, because what's the top?
0.
0. We only mildly care because as long as it's anything except for 0, right? If it was 0, that would be bad, but it's not, so that's fine. So we know that the slope is 0. So now we're going to take the derivative and set it equal to the slope, which we found to be 0. So to find the derivative of this function, we're going to have to use what rule? Function inside of a, something inside of a function. The chain rule. So what's the derivative of the inside? 2. What's 2 times negative 3? Negative 6. Times, what's the derivative of sine?
Cosine.
Yep, of the original inside. That's how you can do the chain rule in one step, and you're more comfortable with it. And we're going to set this equal to 0, which is the slope we found. So I divide both sides by negative 6. It doesn't change the 0. Now here you could kind of guess and check to figure out what x value would work here in radians. But if you don't want to do all of that, you can do the algebra way or the geometry way. If you guys remember, when you want to find what's inside of a cosine or sine, you take the inverse of both sides, which cancels out the cosine. So, depends how good your pre-calc knowledge is. This cancels out and leaves me with 2x equals. In your calculator, if you do cos inverse of 0, you should get 90 degrees. What would be the radian equivalent of that? Of 90 degrees?
1. Or is it 0? I don't know.
90 degrees, pi over 2.
Oh.
Because
Oh,
pi is
sure.
180, right?
I thought asking about.
No, it's okay. It's confusing. I know what you mean.
I never memorized this stuff.
So if you convert it, it becomes, or divide by 2, after you convert it, it becomes pi over 4, which is 45 degrees, right? So our C value is pi over 4. Now keep in mind, if your interval is given to you in radians, your answer needs to also be in radians. Has to match. Okay, so make sure you know how to do your conversions going into this test. It will definitely be a question like this on there. Now looking at this graph, if we look at pi over 4, I don't know exactly where everything is, but you get the idea that we have multiple times where the slope is 0. So that would be our C value. Now if you wanted to find the exact point at which this occurs, you could plug the C value back into the function to find its corresponding Y value. But that's basically it. So let me say one more thing and then I'll help. So the main thing I want to say is that Rolle's theorem is basically the same thing as mean value theorem, except for the slope has to be 0. Now keep in mind, if the slope comes out to be anything but 0, you would just say it doesn't apply and you wouldn't proceed with the problem. Okay? Yes?
So you got pi over 4 because you get 2 pi over 2.
I get pi over 2. Keep change flip. It would be this times 1 over 2.
Okay.
Does that make sense?
Yeah.
Okay. Yeah. All right.